your domain, because you look at your domain and say, all right, so that's my domain. It makes more sense for you guys to find it and find out where your zeros are. Those are your asymptotes. So your asymptotes are always the exception to your domain. Then we say there's another way to do this. Start with your original domain for tangent, no transformations to it, and take whatever is in here and set it equal to whatever that x is equal to. Just like this. Solve for x. And in this case, you can cross multiply, you can set your denominators equal to each other, so your numerators are equal to each other, and whichever works for you. You're going to solve for x, so you have to divide both sides by pi. X is equal to n, and you bring down the original qualifier, where n is any odd integer. So if I was going to graph this, these are where my asymptotes go, because this is where it says except. So if I just wrote out in radians, and if I was going to graph this, I would just write this out in radians and graph off of my radians. My radians tell me where x is equal to n. So n is any odd integer. I have an asymptote here, I have an asymptote here, I have an asymptote here. And you can pretty much fill in your tangent function. Just, if you were going to graph it in radians, and you do graph in radians, you can just renumber this one, 1, 2, 3, 4, 5. I'm not asking you to graph it. I know a lot of you struggle with the radians. I'm just asking you to apply this and give me this domain. I'll only have you graph the ones that work out with like the pi's in them, the ones that you're comfortable with. I don't want you to be uncomfortable with the graphing part. Cosecant, your c's work the same. This one guy has a reflection, but the reflection isn't going to bother my range, and it's not going to bother where my asymptotes go, because the zeros are still at the zeros. So the reflection has no bearing on your domain or range right here. Start with your cosecant curve. Take this piece and set this equal to this piece, and solve for x. And bring down this qualifier. This does give us our even ones because we're multiplying by 2, but we never say it over here. We use any integer over here. Okay? And if it helps, if you have trouble seeing that, do n is equal to 0, n is equal to 1, n is equal to 2, and kind of see where your asymptotes go. These are your asymptotes because these are your zeros. If you think about it, when you graph this, I would graph my sine curve. If you're going to graph this, I would graph my sine curve, and then off of that, graph my cosecant curve. Okay. And you'll kind of see how this one works. And I think we did one similar. So for your 4 quadrants, because it's going to do half of this, it's going to go like this, half of this, and these are where your asymptotes go. So these guys will say, so if n is 0, I'm at the 0. If n is 1, I'm at the 2 pi. Here's my 2 pi. If n is 3, I'm at the 6 pi. And I can keep on going up. So here's your piece, and you just have to graph off of this guy. You only have one little section in here. And then you know that your other curve comes here, and graph your other section. And reflection just moves everything down. It doesn't affect your range, because it's still the same range, and it's not going to affect your domain, because when you reflect this, your zeros are still reflecting on that line. So it's not going to have any effect on this. All I want you to do is use your formulas for this. Secant works like tangent, and pi over 2 where n is odd. The range changed on this one, because we went, instead of -1, we went to -2, and we went to +2 we started. So just change these pieces. Again, set these equal to each other, cross multiply, and solve for x. If you put it on the top, 3n over 2, nope, you can leave it like that. You can't do this. You're fine here, and you're fine separate. You just can't put it on the bottom, right? But you can leave it separate. And bring down your original qualifier, and you're good. sense? Now this one is even very hard to graph. It's 3 halves of n where n is an odd integer. So you'd have to put a 1 in there, put a 3 in there, and you're still going to get a lot of fractions. I wouldn't ask you to graph this. Just find the domain for this. The last one, I know you didn't have this down here. Don't worry about it. We didn't have that down there. That's what we're going to do after we have this test. We'll do the inverses. I won't throw it to you at the same time, just over here. So cosecant works like your cotangent. Your c's work together again. Just take 2 pi x and set it equal to n pi and solve for x. 1/2 n, n over 2, where n is any even integer. And again, my range changed. So instead of the -1 and the +1, I'm at the -1/2 to +1/2. Can everybody do these based off those formulas? There's only 2 that you have to remember. That's your tangent, and it's real. These are your exceptions, so these are where your asymptotes go. And your cotangent. If you just memorize those 2, and tangent you can almost get a feel for, because tangent's like the easiest to graph. You know it goes right in here. Its period is pi. It takes from -90 to +90 to give me one of those little spaghetti guys. And then I'm going to go here and do another one, and go here and do another one. What part don't you get? The frequency. Well, I don't want you to graph those. I just want you to find those over there with your domains. Were you able to do those? So we'll hit a frequency graph in a second. Your secant works the same, and your cosecant works the same as your c's work together, and these 2 work together. Do you remember your Pythagorean identities, cosine plus cosine squared plus sine squared equals 1? Then we did 1 plus the secant squared equals the tangent squared. We did those. They kind of stick together, these guys, and these guys stick together. Okay. But is everybody okay with that? These are the only 2, and the other 2 match up to these. Okay. Graphing them is a little different. Graphing them, remember, if you're going to do this, and let's hit one, Anne-Marie, where this is going to change. So let's just make this say cosecant 2x, right? So what does this mean? In 2 pi. So how long is it going to take to complete one cycle? Half of it, pi, right? I would start this way. This is the reciprocal of your sine curve. The easiest way. This is what I had you do last week. So again, in 2 pi, you had one sine curve that went like this. Now you need to do it in half the time.
But I get it for like cosecant with secant, but I don't get it for tangent.
Tangent? Okay, so tangent works a little bit different. Let's change this to tangent. So tangent normally says, here's my tangent at my 90s. Okay, I need to put 2 of them inside of here. So this same thing that we did for this guy, we cut it in half. We've got to cut this in half. So you're going to cut this in half. And your period is only pi. So now it's going to go like this. It's going to go this way. So if I put a 0 in here, the tangent is 0. No, I'm not going to go like that either. It's got to come through the 0. I know. Let's start this way. So I'm going to cut these in half. It's got to come through here. It's going to go this way at the 45. Is that what mine's doing? No. Still got to come through the 0. Because if you plug a 0 in here, your tangent of 0 is still 0. That one's not going to change. But now your asymptotes are going to be half the distance instead of being at the 90s. So think about that. It's going to be half the distance. They were at every n pi over 2, all the odds, 90, 270, negative 90, negative 270. Now I got to go half that distance because my period on tangent is only pi. That's the different part. So now I got to go 45 here and 45 here. So if my period was pi, half of that distance, this is going to be my new period. From negative 90 to positive 90 was where I went. I got to go half that distance. From negative 45 to positive 45.
So we need pi over 4 and pi over 2.
Pi over 4 would be right here. So my asymptotes are going to be at pi over 4. This is my pi over 2. This is where I used to be. I used to be here. In here. This is my 90. So now I'm half that distance because my cycle for a tangent is not 2 pi, it's pi. So if I cut my new cycle, it's pi over 2. 45 this way, 45 this way. So my asymptotes are at the 45s. Now, when we take this guy and we set this equal to, and pi over 2, and any odd integer, we set 2x equal to this. Cross multiply, divide by 4. Isn't this also at the n pi over 4 every 45, where n is any odd integer? So it's at the 1 pi over 4. It's over here at the 3 pi over 4. I just have to skip over the even ones. These are the hard ones. The tangent's not as bad. The cotangent one is a little harder to get because the cotangent one, don't forget the cotangent one still has a period of pi, but the cotangent one works this way, and it goes the opposite way, this way. So it goes through here. So if you're going to cut these in half, just move them over and start them here. It's got to focus off of this one. The zeros have to stay the same zeros. And the tangent and the cotangent have a period of pi, not 2 pi. Those are different. And I like to do those separate because they're not continuous curves. So they don't work as nicely as the sine and the cosine. Okay?